Hey guys, welcome to week 1 Advanced CAD Guide, where we're going to start combining some of the things we've learned to create a little bit more complex CAD. The gist is you'll be creating a surgical syringe casing um, with uncertain parameters. You'll be creating complex features using just simple sketches and show how we can create advanced things with what we know right now. The scenario is you've been tasked to create this surgical syringe casing in CAD, with the one caveat that the final dimensions haven't been determined yet. So, to implement that, we'll be using the parametric CAD features. Go ahead and open up your parameters, either using the Manage tabs parameters or the small FX at the top of your screen. Here, you'll be able to add a parameter. We'll name it main dia, and then edit the equation that determines its value to be 0.5 inches. And this is a good starting location. From this starting point, we can now create a sketch that uses that new parameter. So go ahead and fire up a sketch on the XY plane and create yourself a circle. Except instead of giving it a number, we'll name it main dia. And you'll see it turns black there as it recognizes the value. So nominally it's half an inch, but the actual sketch is dependent on the parameter and will be updated if the variable changes. Now we'll create a new parameter called main thick. Once again, go up here, add a numeric, name main thick, and we'll edit this to 0.25. Gotta get rid of that first. And there you go. So now, using that new parameter, we'll go ahead and extrude our new sketch a distance equal to main thick. Here we go. And so nominally, the thickness of this is 0.25 inches, but it is dependent on that main thick parameter. So you can change the parameter and it will be reflected in this feature. Now this is where things will get a little hairy. First, make a new sketch off of the face of this part. We're going to create another circle, but we're not going to give it a definite value. Instead, it's going to be the main diameter's length times 1.1. There we go. This means that as we change main diameter, it not only changes the feature we made before, but it will also change this sketch. Go ahead and finish the sketch up. Now grabbing this guy and extruding it. We're not going to give it a real value. We'll instead say it's main thick times 1.2. And get rid of the inches. There we go. And once again, changing main thick will change the thickness of the first feature as well as the second feature. So now we want to create 2 more cylinders off of the 2 we already have. To do that, we'll go ahead and create a new sketch off of this guy. Our specifications say with the current diameter, it should be 0.4 inches. However, we want this to update with changes to that main diameter. So instead, we'll say it's main dia times 0.8. This gives us the same value we wanted, but it's a scalar of the main diameter, so it will update with the parameter changes. Finish this sketch and extrude it. The current value should be 0.25, and because main thickness is also 0.25, we can simply say that this is main thick. And then once again, we'll do that process off of the new cylinder, creating another circle. This one is 0.2 in diameter, and with an original diameter of 0.5, it means this is 40% of main diameter. So, times 0.4. We'll extrude this sketch just as we did before. The thickness should be 0.3. Main thick is 0.25 right now, so we need a 20% increase, which means this value should be main thick times 1.2. This means that with our 0.25 height of main thick, scaling it up by 1.2 should give us the correct thickness. There we go. And here we are. At this point, your syringe stack should look like this. Now we're going to add the back finger grip of the syringe. This won't need to scale up, so we won't use parameters. First, start a 2D sketch on the YZ plane, projecting the geometry for this line and this line. We will create a 2-point center rectangle, right? So choosing this one, centered at the very center of the left cylinder, with a height of 0.2 and a width of 0.05. Go ahead and dimension this right here. Now, we'll create a construction line. The length doesn't matter, only that it be vertical. Distance, 1.5 inches from the y-axis. Go ahead and set that to a construction line, and that'll finish this sketch. Now we're going to select the Revolve tool with a profile of the rectangle and an axis of that construction line, creating this nifty design. As you see, the results should match, and this is the finger hold. Now that we've finished the back finger grip, let's get moving on the other two finger grips. To do that, we're going to use something called a work plane. First, let's create another cylinder off of the other side with the following dimensions. Diameter should be 0.6, and if we know the current main diameter is 0.5, that's a 20% increase, so it should be main dia times 1.2. Now, we'll extrude that sketch to a height of 0.15. This should be back on parameters though, and if we know that the height of the main thickness is 0.25, we want a 20% decrease. %40 decrease. So actually, it will be 0.6. And if you want to measure this out to be sure, yep, 0.15. Now, we'll get started on the nubs that will support the other two finger holds. To do that, let's go to Work Plane with the Plane tool, specifically the Tangent to Surface and Parallel to Plane tool. Selecting this new cylinder, as well as the YZ plane, we go to Work Plane that is parallel to that YZ plane, and it just barely kisses the tangent of the cylinder. We'll create a new 2D sketch using this work plane. Now we know we want this nub to be the same width as the height of the cylinder, and it's a square, so the height of the square should be equal to its width. To do this, we'll create a construction line from the origin out to this line. This allows us to choose our rectangle tool and center it at the center of this construction line. Bring it out to the wall here and give it some height. We know we want the corner of our square to be coincident with the bottom of the cylinder. Same with the top of the cylinder. With these two constraints, we can set the sides equal, creating a square that is dependent on our two parameters in the same way that the cylinder's height was, without having to do all the calculations once again. We'll finish up this sketch now. Now we'll extrude this to create the nub we wanted. Selecting the extrude tool, select this profile. We will actually want it to go both ways. So select the both directions option. And we want a constant thickness. So let's go ahead and enter in 0.15 and hit OK. So here's our nub. Now we're going to create the actual finger holds. To do that, we'll need a work plane that goes directly in between the two surfaces of our last cylinder. We'll create that by using the mid-plane between two planes tool, selecting the bottom and top planes, get a bisecting plane. Now we'll go ahead and create a sketch on that plane. Here we go. We'll head over to the other side of the part because it's easier to envision it from here. And we'll create the sketch given to us. I'm using the midpoint 3-point rectangle tool, creating one with 0.2 height and 0.05 width. Here we go. Now we just need our construction line. The length doesn't matter, but what does matter is that it is 0.7 from the y-axis. I've made the y-axis visible. Now I'll project it so I can clearly get hold of it. I'll dimension out from here to my construction line, 0.7. Oh, no more dimensioning. There we go. Construction line, just to be sure. And we'll finish up this sketch. Now, we'll revolve it, choosing our sketch as the profile and the construction line as the axis. There we go. Now this looks right. We're all about working smarter, not harder. So here, we'll use the mirror tool, selecting our revolution feature, as well as the nub feature, and mirroring it across the YZ plane, we create the other finger holder that we wanted to without having to go through all the different work plane things. Now we're going to create a longer cylinder, once again based off of parameters. So we'll head back over here. We'll create a new sketch. Diameter of the circle should be 0.5, and that was our original main diameter. So we'll just name it main dia. There we go. That's a projected geometry. Go ahead and extrude our sketch. 2 inches. Now if you remember, our main thickness was 0.25, and so that's going to be an 8 times scale. There we go. And headed back to home view. We can see that it looks just about right. Now we're going to hollow out that new cylinder. So go ahead and move your view over here. Create yet another sketch. This one's going to be 0.45 in diameter, which is 90% of our main diameter. Times 0.9. There we go. Finish that up. Grab that sketch and extrude it inwards. Once again, 2 inches, but we want to make this based off of main thick. So main thick times 8. And make sure to turn it into a cut in the opposite direction. Here we go. And now the cylinder's hollow. I can't really see it from this view. Now we want to extrude a slot out of our hollow cylinder. To do that, let's go ahead and start a new 2D sketch on the YZ plane. We're going to want the geometry for the stop point, a stop point up here, and the line itself. Go ahead and use a 3-point slot, placing one point on the outer diameter, the other point on the outer diameter as well, being careful not to get the inner diameter, right? Outer diameter, and making it main thick. There we go. Now we want the center point of each slot to be main thick times 2 away from each wall. So we'll do that one, do this one. There's our slot. Go ahead and finish up the sketch. And we'll use the extrusion tool on this new sketch to push it both ways. We want to cut out main thick times 2. Remember, main thickness is 0.25. We want the extents to be 0.5. So that's main thick times 2. And there's our cutout. We're going to add on some 16th inch fillets to make it look nice. So go ahead and select each geometry you'd like a fillet on. There we go. Radius 1/16. And we'll hit OK on that. And here's our syringe, or at least the holder for it. And to check your work, we'll go to Eye Properties, go to Physical, ensure that your material is set to aluminum 661, and your mass should be 0.032. If that doesn't line up, go back and look through your steps again to make sure that you did it right. If not, you're good to go. Just some things to go over. This guide should show you the basic steps on how to make this part. There's definitely other ways to make these features. There's no one right way to make it. But now that you got this down, you could try implementing other things. Some things to keep in mind, because these are based off of parameters. How does this part change when you start changing base parameters? Can you make this part with only one defined base parameter? Can you make the sketch constraints with only the constraint tools given, without really using the dimension tool as we did previously? But apart from that, um, this has been the Advanced CAD Guide. Thanks for watching.